Hello, Keynote viewers. Let's say you've just finished the hard work of collecting a large amount of rich, clean data, and you're now faced with the task of teasing out and presenting the most important takeaways. If you do it right, your data can tell a story that takes the audience on a journey toward your most important conclusions or findings. And nothing helps move them quite like visual elements such as charts, graphs, maps, and other visuals. But you cannot sacrifice data integrity to visual interest. You have to know not only what makes people stand up and take notice, but also which visual elements best present your key points. Through today's discussion, we're going to discuss how to make informed choices about our visualizations using basic principles of human attention and perception. There's lots to explore, debate, and discuss on this topic here. So viewers, please welcome me in joining David Gold to today's keynote. David, great to have you.
Thanks, great to be here, Chris.
Yeah, you bet. So David joins us from Brooklyn, New York. He is a PhD candidate in environmental and water resources systems with the Reed Research Group at Cornell University. He is also author of a new eCornell certificate program on this very subject called Data Visualization with Python. This is a Cornell certificate program. I will be sharing the URL with you probably closer to the end when we kind of get into what the certificate program entails, what the courses are all about. Audience, viewers, David and I are going to be having a discussion, but we welcome your comments and your questions throughout. So please submit them in the chat up in the top right of your video player. You can simply click that chat dialog box, enter your questions in there, and I'll take them here as we go through the discussion. We are live. This discussion is also being recorded. So if you want to view the recording afterward, if you have to leave early, you want to share this with anyone, it's at the same URL, same page that you are at. So without too much more fuss, David, let's get into it. So I have to ask you, this was my favorite part about our conversation. Well, first of all, let's get a little bit of background first. So you are a PhD candidate in environmental and water resources systems at the College of Engineering at Cornell. So tell us about your research, the work that you do over there, and especially how it relates to today's topic.
Sure, yeah, so I study what's called environmental and water resources systems. And we're in the School of Civil and Environmental Engineering. So one thing that I think is really interesting about my program is that I'm a PhD researcher. So I'm a scientist, I'm doing scientific research, but I'm also an engineer. So that means that research is applied and we're working on real world problems. And so what my research focuses on is how do we innovate decision-making methodology? So how can we improve on what's already existing in the past, use new tools like machine learning, big data. We use things like evolutionary algorithms to try to inform decisions. And really what we're working on is some of the most challenging problems facing infrastructure, facing environmental systems, which mostly stem from climate change, population growth, demographic shifts. And so what my research really focuses on is how can we find new ways to approach these problems to create more sustainable decision-making frameworks.
So you work with computer scientists, engineers, data professionals. You yourself end up viewing a lot of presentations and attending a lot of conferences, research presentations, and so on. In our pregame chatter, our huddle up a couple weeks ago, you had observed something in the presentation of data. You found that you were frustrated or something was lacking. Tell us a little bit about what tendencies you tend to see among people who are working in these professions.
Yeah, absolutely. So, I mean, one thing, I think this comes from a lot of my own experience, both as an undergrad, I also worked as an engineer for a while, and then working in academia was we'd have these, especially in academia, you have these brilliant professors who may come and give a seminar, and they do this wonderful statistical analysis or this new insights from machine learning, and then they try to communicate it, and it's just gibberish, even for people who are trained scientists or trained engineers. Oftentimes without effective data visualization, you really can't understand what somebody is trying to say. So I've seen many presentations where somebody will show a figure and it's just a mess of data with no organization, or you can't read the labels on the plots. You can't understand what they're trying to say. I should also say that in my own experience, when I started as a PhD student, I ran into some problems when I was working with real world stakeholders. So one of the great things about my PhD program is I actually get to work with people who are making these decisions in real life. And I use, complex machine learning, statistical methods, and I would take my research results at the very beginning of my PhD, and I would try to show them to these real world decision makers who often are extremely smart, but don't have the training in statistics or engineering. And they would just give me these very skeptical looks, like, I don't know what you're talking about. Can you say this in English? And so that really made me need to like deep dive into visualization. How can I actually take what I'm doing and communicate it to an audience so that they understand it? And this really turns into, how do you tell stories with your data? How do you develop a narrative that people can understand? And honestly, you can do the best, most interesting science work. And if you can't communicate it to people, it's not very useful.
Exactly. You know, storytelling is kind of a new concept, a new application to this type of work, right? I mean, nobody was talking about storytelling, I don't know, maybe 10 years ago, certainly in any of these fields. So, and this happens, right? This permeates all professions. I think a lot of our audience probably understands the concept of storytelling, whether you're in sales, whether you're in marketing, whether you're in anything, service, and so on. So I'm glad you brought that up. So let's dig into a little bit about, let's dig into the framework for your thinking, right? So let's look at some I want to look at a couple slides here. I think we should distinguish between the types of visualizations. Let's talk about what we're talking about here and baseline it for us, David, if you could.
Yeah, excellent. Well, I would definitely recommend this book, which we centered the course around, called Storytelling with Data. And one of the premises of the book and one of the premises of the course, which I've really seen in my own experience, is that data visualization is a skill. So one thing that I've been frustrated, and again, this is changing, but when I went to college and got a degree in civil and environmental engineering, I thought I really got a great education in all the technical aspects. Even in written, verbal communication, it was really solid, but I never got a course in how do you tell stories with data? How do you effectively communicate that actual data? And there's no actual right way to do this, but there are many wrong ways, as I was mentioning earlier. And so there are some best practices and some insights that we can take to really improve how we make data visualization. And it is important to distinguish that there's really two main types of using visualization when looking at data. There's exploratory data visualization, which is when you use data visualization tools to get insights from data. So this would be like using it as a way of saying, I have this big data set. This data set is maybe multidimensional or complex, and probably both. And just by looking at this data, maybe in a tabulated form, there's no way I can make sense of it. So that's where exploratory data visualization comes in. You can use visualization to actually learn about what you have and develop insights. There's also explanatory data visualization. This is what I want to talk about most today, and this is really where communication comes in. This is when you've already done your analysis and you need to communicate that to the outside world. So that might be communicating it to your boss. It might be communicating it to fellow academics. It might be communicating it to the general public. And so that's really what we're going to highlight today. And to talk about this, I've developed a couple scenarios. These are loosely based on the Storytelling with Data book, but I developed these on my own. So scenario one, let's say you're a data scientist and you're working for a research institute that's developing a new pain treatment for a chronic disease. And you've done years-long experiments, you process the results, and you discover that patients undergoing the treatment reported significantly lower pain levels compared with the control group. And so the kind of basic way you could view this data would just be in tabulated form. So here we have 4 potential responses to this survey. They could report no pain, mild pain, moderate pain, or severe pain. And then we have the results from our control group and our test group. So one way we could visualize this data, and I would call this kind of a naive way, would be to put in a pie graph. And so this plot is not incorrect. We have our control group on the left here and our treatment group on the right. And we have each of the responses in colors. And so if you look at this visualization closely, you can get what we're trying to say. You can see that, for example, the moderate pain group has a very high fraction of the responses in the control group, whereas it's less in the treatment group. And then mild pain is much greater, as well as no pain in the treatment group. But you really have to look hard, and you have to actually have a lot of brain power to make sense of this data. A better way of visualizing the same data would be to utilize a visual hierarchy to present this data in a different form that is maybe easier to comprehend, and then to guide the viewer through this visualization. So this is the exact same data, but we've applied some of the concepts of psychology and visualization best practices. And really, if you read through this data, it goes from left to right. You can really understand the story, which is the new treatment is able to greatly reduce pain from this study. We have another scenario that I've cooked up that's kind of demonstrating this with a different scenario. So in this scenario, you're an executive at a technology company and you've spearheaded the development and the launch of a new product. And since this product was introduced in 2010, it's sold very well and you think it's transformed the marketplace. And you look at your sales and this belief is confirmed. So if you look at this table, again, I imagine everybody viewing out here or viewing this presentation isn't gonna look at this table and instantly understand what's going on. So you might try to make a visualization, and here's an example again of a bad visualization. This is the same data from that table. We have our company in blue and the competitor in orange. And if you look at it, you can see, yes, our company is doing better. The blue bars end up higher, so we're looking at sales. But notice there's not much labeling on here. It's very cluttered. It's hard to understand. So here's a better visualization of the same data. Here we clearly highlight our company. We clearly highlight the competitor. We highlight that we're showing annual sales over time. And we also add, again, some annotations in a visual hierarchy that guides the viewer through what we're trying to say. So in this plot, you can clearly see that starting in 2010, when our product was launched, our company's sales has taken off. The competitors has started to dive. And so this is a very effective way of creating this narrative or telling the story that's actually in this data set. So maybe I'll pause there to get back to some questions. Oh, I think you're muted.
I sure am. I wanted to ask you, when you're thinking about presentation, there was mention earlier about the science of aesthetics, using visual elements for like knowledge transfer ultimately is what we're talking about here. So how do you think about your audience when you're building a visual? I mean, that's obviously prime consideration, right? You have to speak their language to some degree. How do you tune a presentation to a particular audience's, their attention span, perceptions, I don't know, if you're the 10th speaker in the conference, you have to think about all these things. Absolutely. I don't know. Tell me a little bit how you think about audience.
Yeah, I think one of the most important things about audience is actually the form that your visualization is taking. And what I mean by that is if you have something that's print, so maybe it's an online article or a research publication or a report that you send to your boss, your audience is a reader versus your audience being somebody who's at a live presentation. So when you have something in print, you have to make sure that everything is there for the reader. Everything that they need to understand your point is included in this visualization. While if you're doing something in a live presentation, you actually have control. So you can build up your visualization. You can explain things as you go. I can point to things with a laser pointer and talk about them. And so I would say that the first thing about your audience is knowing whether your audience is somebody in front of you or somebody reading this who you can't talk to. I think beyond that, in terms of your actual audience members, that is one of the most important things when you're making a data visualization. So I would make a different data visualization if I was talking to a room full of academics versus if I was talking to the general public about a research. And this could be in terms of how much data do I show. So if it's a room full of academics who already understand maybe an established physical principle or a manifestation of a certain concept, then I can just say, here we're looking at, the Manning's coefficient and how it changes with response to surface roughness or changes with response to the type of surface versus, if I'm giving something to a general public, I might have to explain what that means and try to make sure everybody is following what I'm saying. And so that, again, there's not necessarily, this is going to be different for every single application, but oftentimes, you're the one working with this data, thinking about the audience and having that be your starting point can really be a way to kickstart the process of this visual storytelling.
Speaking of audience, so we have a little bit of a cross-section. I asked pretty early on what fields or industries are people working in. We've got education, state government, law enforcement, consulting, plastic surgery clinic, county government, business analytics, clinical research, regional water utility. So an interesting cross-section, right? A lot of public and municipality affiliated organizations there who have to present for constituencies, for government people, and so on, right? So it's just kind of interesting to see that, but I think we should probably kind of bring it back a little bit. And, viewer Denise asks, what tools are you using to create these data visualizations? You had mentioned Python. Tell us a little bit about Python, why you choose it, what's good about it, who should learn it, and all of that involved.
Yeah, great. Well, I guess I will first say there's a whole variety of different data visualization tools out there. From even Excel, you can make nice visualizations. R is a programming language that makes very nice visualizations. There's professional software like Tableau. But I personally, I love Python. I use Python all the time. One thing that I like about Python is when you have big data or complex data, it's something that you can, if you have data analysis scripts or you're running a model, you can seamlessly integrate Python into the rest of your workflow. It also has very powerful libraries for data management and for statistical analysis. It's free, it's open source. It's a library or a language that is constantly being improved and updated. And it's pretty accessible. You don't need to be a computer scientist to understand Python. So those are the reasons why I like Python. I think if you're somebody who's not interested in programming, you can create, with some of the principles that we outline in our eCornell course, you can create very effective data visualizations on a software like Excel. It's all about just knowing your story, knowing your audience, and then using the right techniques to make a good visualization.
Yeah, I alluded early on that there was going to be just some debate and challenge, and I did get something in from Craig Jacobs who says, in the second example, I think that's the one we're looking at here, it feels like the data is manipulative. There are many other potential factors that would cause sales improvement or competitive decline. Do stories need to address legitimacy?
Yes, so that's an excellent question. For full disclosure, I made this data set up to contrast the second line plot with the first bar plot. So I think the most important thing, actually, like the golden rule of data visualization, is you can't make up the story. So the story has to be there in the data. Now, I would argue that this plot is a demonstration of we have a fact. Our company introduces a new technology product in 2010. Then our company takes off, the competitor dips. This plot does not prove that that is why it dipped. It's just showing that this is something that happened. But really, like I was saying, the golden rule in data visualization is the data visualization has to be something that allows you to narrate your story. It shouldn't be the story in itself. And there's actually some guidance in terms of how to make data visualizations with integrity. So I'm going to skip ahead for a second in this presentation. But here's an example that's in the Storytelling with Data book. And this is an example of what Edward Tufte, who is kind of a legendary data visualization pioneer, really, he calls this the lie factor. So this is an example from, I don't know, maybe this is 2010 or 2011. And here they're showing the impact of tax cuts. And I think this was maybe that there were Bush era tax cuts that were set to expire. And this data visualization is saying, well, now we have our tax cuts at 35, or our taxes at 35%. For the top rate. If they expire, they'll go to 39.6. And from this visualization on the news screen, this looks like a very dramatic increase. However, the reason why this looks so dramatic in this case is because they didn't start the axes at 0. They started the axes at 34%. And so Tufte introduced this concept of a lie factor, which is the size of the effect in the graphic divided by the size of the effect in the data. And in this case, the size of the effect, if you actually measure it out in terms of, I think I use centimeters here, it has a lie factor of 5. So they are exaggerating the effect in the data by 5 times. So one of the key elements in terms of having a data visualization that has integrity is to have a 0 lie factor, or it would actually be a lie factor of 1. You want the data to exactly represent, or the visualization to exactly represent the data. Now, I think this is, teaching data visualization is kind of fraught because the tools that we use to make effective visualizations can be used to manipulate data. I also think, though, as somebody who might be interested in learning about this, if you learn these tools, then you also get better critical thinking skills, and you can understand how to spot that type of manipulation. So it's always going to be out there in the world. Really what we need is people to be aware of how can these visualizations be manipulated. How can you make sure that your data visualizations have integrity, and how can you learn to call people out when they're manipulating their own data?
Perfect. We've got a little bit of input from the audience again, and there's a couple kind of emergent themes that are happening here. People are curious about platform, or the software choice, right? Python versus Tableau versus Excel. I think everyone's kind of interested in how you would distinguish between those pretty quickly. Like,
Sure.
Who should use one versus the other?
Yeah. So I would say a big distinguishing element is cost. So something like Tableau is very expensive. You have to buy an expensive license. So there are many companies that purchase these licenses and have deals with Tableau. Tableau has professionals who work there who can consult on your data visualizations. They can make very high quality data visualizations, but you have to pay for it. Then there's something like Excel, which is also not free, but I think it's cheaper and it maybe is easier to access than something like Tableau. But Excel has, and this has actually been changing. I've been impressed with how Excel has evolved over recent years, but their baseline visualizations that they make are often quite ugly and quite cluttered. And so when you're working with Excel, you have to do a lot of work on the back end to customize your visualization and to really make it effective. Then I would say that actually highlights the second element. So the first is cost. It's something that distinguishes these platforms. The second is your ability to customize. So one great thing about a scripting tool like Python and R is that if you understand how the language works, you can actually build a visualization up from the bottom. So you can customize every single aspect of the figure, whether it's your color palette that you're using, which usually you can customize that across different platforms, but you can customize how the axes look, you can customize the grid lines, you can customize the type of points, how they're spread. And so their scripting languages are highly customizable, whereas packages are often harder to kind of go in and edit. I would say there's one more key element, which is the platform's ability to integrate with different types of data and different sizes of data. And so again, languages like Python and R are built to work in high performance computing environments. They're built to work with machine learning tools, with big data sets. And so having those as part of your workflow, understanding how to use those languages can be really beneficial. I would say that it's not universal. So which platform is right for you is really going to depend on your own context, the work that you're trying to do and what you want to get out of it, how much control you want to have over your visualization.
Good. Thank you for spending a few moments on that. Power by keeps coming up in the chat as well, which seems like another competitive platform, or at least a common one that's typically used. I have a good question from Andre, who asks, best advice for a new grad who is in the data visualization analysis field. What to focus on for new grads, right? It can be hard to focus on all aspects of good data at once. Any advice for someone who's relatively new to the field? A lot in that question, but I don't know, any quick advice there?
Yeah, I mean, I think a simple advice, or a simple piece of advice, which is a key theme in what we're talking about, is that data visualization is data communication, and identifying the story that you're trying to tell and then stripping out all elements from a figure that do not tell that story, again, as long as you're keeping the data integrity intact. That is often the most important thing. So one thing that we talk about in our eCornell course is reducing visual clutter and using a hierarchy of information to kind of draw the viewer's eye and highlight key points. And so I would say for a new grad, and especially, I had a STEM education and this wasn't really highlighted, is make sure you actually take time to design every figure that you're making, and make sure that that figure is a medium that you can use to narrate and to explain what you're trying to say. And that will really take what you're doing from a kind of a visualization that feels maybe hard to read or hard to understand, to something that is really a medium of conveying this information. And I think that's really important for everyone who's trained in STEM fields, but who wants to communicate out to the broader world. So maybe you have a data science degree and now you're working in business, or you're an engineer and you become a manager, or you're an engineer and you're just trying to talk to your clients. Just being able to communicate and tell that story can really be transformative. And that can often be the difference between getting a proposal funded or getting rejected, or getting a promotion or not getting a promotion. It's all about how you present yourself, and doing that professionally, clearly, and articulately is extremely important.
I was kicking around on Twitter before we got started today, and Alex Svanevic on Twitter said, pro tip on data visualization, don't get creative. I'm curious how that kind of figures out, because, you know, you had mentioned, and I think there's another theme emerging here about design aesthetics, how people learn, how they take in information. How much do you have to know about that kind of stuff? And I mean, when you're learning the programming of Python, for instance, how do you integrate some of those design principles?
I mean, I think it is really important. So Tufte again has this I can't remember the exact phrasing. I think he calls it a visualization duck, or a duck plot, and that it's from this story in architecture where some modern architect had a critique where they were saying that you don't want the building to be completely decorative. Like there's a function. So architecture is supposed to be the design of a building. It's not supposed to be the decoration itself. And I don't know too much about architecture, so I don't want to get off on a tangent. But the idea of a duck chart is one where the decoration takes over the plot. And so maybe it's all about the colors, or it's all about this fancy new type of plot that you're using, and you really lose the data. So Tufte's quote is, above all else, show the data. So I don't know if I would agree that you should never be, you definitely need to be creative when making data visualizations, especially for certain contexts. But I already said the golden rule. One of the core rules of data visualization is show the data. So don't mess around. You know, in this plot, we don't need to have one of these, or I don't know if my screen's still sharing, but in our live factor plot, we don't need to make one purple and one blue. We don't need to use colors when colors don't need to be applied. We don't need to have a fancy logarithmic scale. And in fact, in this case, we shouldn't. It would be misleading. So I would maybe rephrase the don't be creative to keep it simple. You know, what's your story? Find out what you're trying to say, and then don't go beyond that. Tell the story that you want to tell. Control the narrative of the information. Don't get people distracted or confused by having extraneous bits of information or extraneous odd types of visualizations that you think look cool.
In visual presentation, I mean, are you concerned with another couple things that are kind of emerging in the chat here is accessibility, color blindness,
yes,
along those lines. What do you think of that? It's becoming tremendously important, even in some of the work we do. I feel like we're always chasing it. We're a little bit behind. Yeah. What's your experience?
Absolutely. So that's, I mean, one of the rules that you do learn in undergrad engineering or STEM fields, or at least I learned, was you always have to be careful when you're making your visualization, especially when using colors, because, you know, if you have a green line and a red line and somebody who's colorblind looks at that, they're both they'll look very similar. And again, above all else, we want to show the data. So we don't want to make a beautiful rainbow of a plot that nobody can read. That being said, I do think there's room, you know, that leads many engineers to make these very ugly looking black and white plots that feel very stale and lifeless. There are all types of colorblind safe palettes out there. And really what you're varying is maybe the hue or the contrast between different colors. And I do think that aesthetics are important. I do think that it's helpful to make visually appealing and striking plots. That shouldn't be the main element of a data visualization. It shouldn't be your main consideration when you're making a plot, but using colors can make it jump out. It can make people's eye get caught by the visualization. It can make them more interested in what you're presenting. And there are clear ways. If you Google colorblind safe color palette, you'll find a ton of different examples. So I would say almost these days it's easy to avoid that trap, but it is very important. Because that can be something, you can have a beautiful data visualization, and if people can't access it, it's not very useful.
You know, maybe it's coincidence, but I doubt it. With the proliferation of data, just analysis, the the amount of data that we've been awash in over the last 10 years. And then you saw the emergence of infographics, which tended to be maybe to a fault, perhaps too creative. And right, maybe we've kind of come back to like, all right, let's dial that back. Let's make it about simplicity and clarity and all those other things, right?
Yeah, absolutely.
Perfect. Okay, so let's talk about the Tufte book, because I did share his. You've mentioned him a couple times. I shared the URL to his book. He seems to be the gold standard, certainly somebody that's wildly popular in this field. Maybe for those of us who aren't familiar with his work, like me, what's in it for me when I read some Tufte?
Yeah, I mean, he is really a pioneer in data visualization. He does a lot of interesting things in the art world, actually. He has his sculptures that he makes and art exhibits. And he is really about I think his book is the visual display of quantitative information. So he is at heart also a statistician. His book has some really interesting ideas about how can you convey a rich amount of data, a large amount of information into a simple plot that people can understand. And so he does a lot of looking at the history of data visualization, starting from, there's a story of John Snow and the Broad Street Pump, which goes back to a cholera epidemic in London in, I believe, the 17th century. And nobody could understand what was the source of this cholera epidemic. And this early statistician, John Snow, he plotted all of the cholera outbreaks. He used a map of visualization, and he was able to learn that, wait a second, these are clustered around one specific pump. There's a story which is actually apocryphal, which is that he then took the handle off the pump. He actually just shut it down. He told the authorities they stopped using the pump. And that stopped the cholera outbreak. And that was a seminal moment. And environmental engineers, we claim him as the first environmental engineer. Public health people say he's the pioneer in public health. And data visualization people also say he was the first, or one of the first people to effectively use data visualization. And the reason this was more on the exploratory side of data visualization. So using data visualization to learn insights from this data. And if you just looked at all of these locations in a table or a plot that didn't have the geographic element in there, you were going to miss the root cause of this epidemic. There's other examples that he draws from history. There's a great, I think this is more on the line of an infographic, but it's a graphic of Napoleon's march into Russia and then his subsequent retreat. And Tufte does a great job explaining why this graphic is so effective. You see the size of Napoleon's army when it goes in. They also juxtapose the temperature in Russia over the winter with this. And as time goes on, the army is shrinking and shrinking until it's just this little sliver. And it's a very effective, I think that was in like 1869 or something around there, but it's a very effective early use of, that would be explanatory data visualization, where we already know Napoleon went into Russia and lost. And this is an effective way of showing what happened. Not quite how did it happen, but how much did his army shrink, and how can we learn from that? So there's all these, the book has all these great historical examples. It's not just, I think it's statistics for people who find statistics boring, and he makes it exciting. He does a great job, and visualizations are really a key part of that.
How about dynamic dashboard visualizations? Does that fit into your purview? Maybe there's a distinguishing, some factors to be made here, but it seems like you're kind of like involved in the presentation of data, and it's kind of a static representation versus dynamic. What do you think about dashboards and all that kind of stuff? Where does your work?
I think that's the future of data visualization. Is I think in the past, if you look in Tufte's book, it's going back to the 17th century, right? Where somebody has a map on a grid and they're measuring it out and plotting dots by hand. Then in the 20th century, we started using computers. We're able to do all these things to make much more advanced plots, things with bigger data. But until, really the last, maybe depending on how fast of a computer you had, the last 5 or 10 years, interactive visualization hasn't been something that was really possible, especially as you get large data sets. So there's new libraries like D3, which is a JavaScript-based library, which is all about creating interactive visualizations. I would say this is, well, I think it's applicable to both data exploration and data explanation. I think probably the way it's being used right now is more for data exploration. So you can have another key part of this is linked visualization. So showing the same data set across multiple views, and you can manipulate it. Maybe you can, scale it under one view and see how that transforms the other view, or you can have a model and you can input certain settings into this model and it will show different facets of the model or the output on different visualizations. And so I think both dynamic data visualizations as well as linked data visualizations are really helpful in terms of narrative instruments for exploring and explaining big data. And I think that we're rapidly seeing increases in the acceptability of these types of tools. You can certainly do this with Python. And I think that's really the future of the field.
Yeah, and just as you were speaking about that, Mara chimed in and asked about whether or not you could elaborate a little bit more and distinguish between exploratory versus explanatory. Tell us a little bit about some other applications for exploratory, for instance, because I'm actually curious as well.
Yeah, sure. So a good example was Jon Snow and the Broad Street Pump. So thinking about what can we learn from, so he had a raw data set, right, of a number of people who had cholera. And then he had the idea of, well, let's look at where these people lived. And so that was one piece of data. And then plotting that geographically allowed him to find this pattern. So by plotting it, he was able to discover this pattern. And then by looking hard, doing more analysis, they realized, wait a second, this is all near this one pump. What if we close down this pump? All of a sudden, cholera epidemic, I don't want to say it was over, but I think it really helped it. So that would be a great example of exploratory data visualization. Mm-hmm. Another useful, so in my work, we often deal with multi-objective trade-offs. So maybe we're working with a water utility and they're interested in examining a water reuse strategy. And they want to know, all right, I want a strategy that minimizes my costs, but also maximizes my reliability. And so what we can do is we can use modeling to get a whole suite of trade-offs of different design options. And we can explore how these trade-offs or how each design option performs in both cost and reliability. And actually in our real research, we often have 5 or 6 objectives simultaneously. And so looking at that just with the raw data, it's almost impossible to make sense of it. There's what's called cognitive overload, where my brain can't quickly enough look at 6-dimensional patterns on a table. But if I put it into a plot and then I am able to interact with that plot, I can say, okay, I want to make sure my reliability stays above 99%. And then, I can brush the data to that and I can say, all right, how does that impact our cost? How does that impact the environmental benefits of this program? And so that can, by doing this interactive and exploratory data visualization, it allows me to find patterns or derive insights that I couldn't do without it. That's different from the explanatory data visualization, which is when I find these patterns, I turn around and I go to the water utility and I explain to them, these are the options that you have. Here's how I found it. And let me take you through my methodology. And then let me ask you, is this correct? Or should we go back and revisit this? And so those are two sides of the project. The first is me trying to gain insights using, complex model results. And then the second is turning around and explaining those insights to somebody else, getting feedback and maybe tweaking them.
Perfect.
Really.
Mara seems to be all over it today. She asks, can you show an example of what the multi-objective trade-off is that you're discussing there?
I don't have one up here. I could find one on my computer, but I feel like that might take a second. I'd be happy to post it on the page afterwards, if that's something we could do, Chris. I could, if you want to give me a second, I could absolutely find one.
Yeah, you know what? Spend a moment doing that. Let me just chat with the audience really quickly. So here we have David Gold, who's PhD certificate author for several courses. Here are the courses that are involved in the certificate program. I'm going to share the URL with you in just a moment. In this certificate program that David Gold has authored, there are Python fundamentals, storytelling with data, and plotting visualizations with Python. So those are three of the courses, and that is, of course, an elective course as well. Thank you for submitting some of these questions here. And for those of you who are just checking in, I saw that this question came up. Yes, this is being recorded. You can view it at the same URL afterward. So just give us a few minutes after we're through today, and you can watch the presentation from the beginning. So David, it looks like you've got something kicked up. What are we looking at here?
I've gotten something kicked up. So here we're looking at and I won't get into the details of my research, but we're looking at 3 different policies for a cooperative water supply planning system. And we're looking at these in 3 dimensions. And so we have 3 different cities, and we're looking at the robustness of this water portfolio for each of these cities. And so pretty much what robustness means is how stable is this policy across climate change and population growth scenarios. So an ideal point would be something in the top corner of this plot, which is each utility is perfectly robust. In this research paper, I'm highlighting 2 ways of finding a compromise. This one's what's called a least squares compromise, and this one's called a power index compromise. And what we can see is how these 2 compromises are different for the 3 utilities and kind of the relative benefits and problems with each of these. If I was doing this with stakeholders, I would want this plot to be interactive. So one drawback of this type of 3D visualization is that we have to kind of use, our brains are making some approximations about the depth and the perspective of this plot. Another way, and I don't want to go too deep, this is called a parallel axis plot. So here we're looking at 5 different performance objectives for these regional utilities. And this is a really interesting type of plot. So we were earlier looking at a 3-dimensional plot. And that plot, you can show 3 dimensions very easily. Again, you have maybe perspective problems that can help to interact with the data. You can also show we showed another dimension in terms of the color of each point for which type of compromise it was. You could also do things like varying the size or maybe varying the intensity of the points. And so those are ways that you can get maybe 4 to 6 different attributes on the same data set or the same plot. But it can get very hard to work through that. So the parallel axis plot is a really interesting way of visualizing high dimensional data. And so what this plot is showing is that instead of having each attribute of the data on a different X, Y, or Z axis, we have each attribute on its own parallel axis. And instead of having each point be represented by an actual point on a plot, each data point is represented by a line. So in this case, we have our 2 compromise portfolios, and we're looking at their performance across these different objectives. And what we can see is where the line crosses each axis is the value of that policy for the given objective. And I know this is kind of like a deep dive into water resources engineering, so I don't want to get into it. But when you study these plots, you can very clearly see trade-offs. So we have, this is called a restriction frequency, and this is the net present cost of infrastructure. And we can see that these 2 policies have a very clear trade-off between these 2 objectives. This is a cost objective for drought mitigation costs versus infrastructure costs. We have another very clear trade-off between those. I'm happy to post some literature about this. This is normally when I do this in my grad course, I would spend maybe 20 minutes explaining and introducing parallel axis plots. But I think this is an example of a new type of data visualization that can highly or very efficiently convey large amounts of data in a kind of condensed form.
Good. Well, I really appreciate you kicking up these visuals for us on demand. I have a couple questions here from Stephanie and Catherine, who checked in back to back. Stephanie asked, any suggestions on how to approach this for someone without a statistics background? And then Catherine asked moments before that, how heavily does data analysis lean on statistical modeling? Can someone from a non-mathematical background aspire to be a data analyst, or should they solidify their understanding of statistical concepts and modeling first? Any advice there?
Yeah, those are very good questions. I would say that the principles of data visualization, the principles of having data visualizations that have integrity, having data visualizations that are effective, do not necessarily need to be associated with statistical techniques. So you could be somebody who's working at a small business and you want to show your sales revenue over the last 5 years. You can certainly apply statistical techniques to look at trends or to understand how uncertainty might affect them. But if you just want to be looking with some data, so you have data, maybe sales revenue over the last 5 years, and you want to plot that, and you want to maybe either talk to your boss about it or show it to investors, absolutely these principles of good data visualization are applicable. They don't have to be statistically oriented. I would say much of Tufte's work is derived from statistics and about information and taking complex quantitative information and plotting it aesthetically and clearly. A lot of the best practices that are in the Storytelling with Data book, I think they're independent. So that book is meant for the business world. It's meant for the professional world. I think that anybody and everybody, in my opinion, I think everybody should have a literacy of data visualization and data basics. As for the other question about data science, again, I think it's valuable to understand visual narratives, visual storytelling, elements of data visualization for clear communication. I think data science is really rooted in statistics. So if you want to be a data scientist, I would definitely advise learning some statistics. And the kind of basic statistical concepts can go a long way. I think you muted. Oh,
gosh, just not used to doing that. So the prospects for somebody that's working in data science that might educate themselves on data visualization, is there any particular exciting growth in any areas? Are there more opportunities somewhere that didn't exist previously? I mean, I'm sure a lot of this is universally applicable, but I don't know. What do you see out there?
Yeah, I mean, I think one thing that is amazing with data visualization is how quickly the field is evolving, and that's really because our computer graphics power, our computing power, has really transformed again over the last decade. So if you look at the most advanced PowerPoint by top scientists in 2005, they might be, they're effective and they're often, very, or if they're top scientists, they're going to be very intelligent analysis. But if you compare their visualization to one that a fifth grader makes, maybe not a fifth grader, maybe an eighth grader makes in 2021, the eighth grader just has access to powerful tools and color palettes and graphical rendering. So I would say that, to me, a very exciting area is the way our platforms are evolving under our feet. So I'm sure the cutting edge platform today is not going to be the cutting edge platform 5 years from now. Now, luckily for something like somebody who does Python, Python is something that's evolving with that. So as new data, or as our graphical power gets increased, as we learn more, as we have more aesthetics that are built into our baseline visualizations, those are being incorporated actively into packages like Python or languages like Python. I would say interactive plotting is a really exciting aspect. There's even people who are looking at using virtual reality for data analysis. Having also highly connected data analysis. I think one thing that we've all learned in the pandemic is how to work remotely. And so being able to collaborate, and maybe where you have multiple people interacting with the same data set collaboratively, can be very powerful. There's been some interesting examples. My major professor used to use one in his decision analysis class that showed like the disaster response room in the future. And this was maybe in 2010. And a lot of what they were predicting really came true, where you have multiple heads-up displays. They had an example of, I think it was a fire team covering a wildfire, and they were able to quickly convey, they analyzed data in the central command center, quickly convey it out to people who are actually fighting the fire. They'd have a heads-up display and a map that could say, you need to go over here, and here's what you need to do, and here's why. So I'd say real-time synthesis of information, abilities to dynamically interact with information, and then just overall improved power and computing power are really exciting areas, in my opinion.
It may be no secret to the audience that I'm not an authority on this subject, but Noshad asked a question which got me thinking. Where can you find big data sets to perform analysis, especially government-funded surveys? So I'm actually curious about compiling data, reconciling it, checking its integrity. How do all those processes work for us lay people? How do we understand that?
Well, that's a really good question. I think it's really going to vary on the type of data. So I work in water, in the environment. Often the data sets we work with are not public because, there's a lot of security for good reason on things like water information, on people's water use data. It's not something that you can publicly access, and it really shouldn't be. There's privacy issues involved. The government actually does have a lot of big data resources. In terms of things to practice on or to just look at interesting patterns. There's websites like, I think it's Kaggle.com, which has machine learning competitions. And so they will post these big data sets. I've used it in computer science courses at Cornell. And it's just like, here's the set, see what you can do with it. Also, the Storytelling with Data website does a nice job. They have, I think, like a challenge of the week or challenge of the month, where they put out a data set and it's just kind of open call. Anybody, here's a data visualization, here's the data set behind it. Can you do this better? Or can you do this in a more interesting way? And it's a really interesting kind of open community where people are taking these data sets and applying their own visualizations, being creative or not being creative. And so there's a lot of interesting opportunities. I wouldn't say there's like one central source that I personally turn to, but there are a myriad of sources out there.
Peggy mentions that people analytics is a growing field. Just moments before that, somebody had mentioned people analytics being used in the HR world, of course. It goes far beyond visualizations, providing predictive insights, such as which employees are likely flight risks due to low engagement, or career progression and stuff like that. How about predictive analytics, and how does that figure into your business here?
Absolutely. So, I mean, predictive analytics are fascinating. I do water. Forecasting is huge in water, right? Understanding if there's going to be a rainstorm coming is really key to if you're managing a water supply dam. You need to know, should I hold this water because people are going to be needing it because there's going to be a drought, or should I release it because there's a flood coming? Data synthesis and predictive models are essential. I know there's a lot of, this is a hot topic in machine learning. I would say where I come in with data visualization is understanding what those models are doing. So one difficulty with machine learning, which is another area of active research, is they're often black boxes. And they're often, a machine learning algorithm, it's artificial intelligence, but always these algorithms are only as good as the data that they're getting. There's problems. There's been problems in the past with these algorithms containing biases, whether they're racial biases or biases about income or things like that, that have been problematic and rich topics of discussion and sources of controversy. So I think one area where data visualization is relevant to that is to try to understand what's going on with these algorithms. What are the decisions that they're recommending? Do those decisions make sense? Are those decisions biased? And that data visualization would really only be one part of that process of exploring it. There's all types of statistical techniques that you can use or other machine learning derived ways that you can examine how an algorithm is performing. But the data visualization is really essential, and that would be on the exploratory side of data analysis. So if you have this powerful algorithm that's making recommendations, as a decision maker, you're going to want to know what's going on. Why are we seeing this recommendation? How is it working? And again, this is an area of active research. I don't think it's a question that's been answered yet.
Yeah, perfect. Peggy, among others, Cindy also asked, please spell some of those data visualization competitions. Apparently we breezed through them too quickly. I didn't have a URL to share. Peggy dropped the community storytellingwithdata.com, but there was a previous website that you had mentioned.
I think it's Kaggle, Kaggle, or maybe it's EL. I can check. Let me check right now.
Okay, I suppose we could do it that way. Yeah, exactly. So thanks everybody for chiming in on that.
Okay, I have it here.
What is it?
It is Kaggle.com. I believe it's Kaggle.
There you go. And what do we learn from this site, or what do we get?
So this site, they have big data sets. I've used them when I was in undergrad doing course projects. If you want to look in and analyze something fun, they also have machine learning competitions that real serious machine learning people will enter and test their algorithms on. And there's a good, I think, just kind of community and dialogue. I think they might have some tutorials and notebooks and examples. So it's really a helpful resource.
Perfect. Now for the data visualization, some of the URLs and resources and courses that we offered, who does this apply to? Who has the most to learn from your certificate in data visualization? Who should maybe stay away from it? Who's it for?
Well, I mean, I really designed it because I've gone through, I'm in my PhD now. I'm almost at the terminal point of STEM education. You can't go beyond a PhD. But I've taken, tons of courses in statistical analysis and optimization and data processing, and never once did I really feel like I was given the tools I needed to effectively communicate data. And so this course is really for anyone who works with data. That could be, you could be in marketing, you could be somebody who owns a small business or works in a small business, you could be at a massive company, you could be an engineer, a manager, and it's all of, if you work with data and you need to tell stories with that data, I think this course is extremely helpful. I designed this course, again, to fill that gap in the STEM curriculum. Engineering management is our program that this falls under. And so these are people who are, and it's a very broad program. It's people who are engineers, but maybe they want to do some type of applied engineering in the business world or in the nonprofit world. And so if you work with large data sets and you want to learn Python, this course is for you. If you just want to learn the best practices of how do I give a convincing presentation to my boss, this course is for you. If you're somebody who's curious about Python and curious about data science, I think this would be an excellent introduction course. So there's really a broad swath of people who I think would be benefited from this course.
Perfect. Any other recommendations on how people can follow the world of David Gold? LinkedIn, where can people get a hold of your stuff? Do you have a blog or anything to
I do. So we have a research group blog. It's called waterprogramming.wordpress.com. If you Google water programming blog, that is an excellent way of following it. I would also point everyone to my research group's website, which is read.cee.cornell.edu, and can I post in the chat?
Perfect.
Beautiful.
Excellent.
So those are the two best ways. Our water programming blog is a collaborative blog. I post on it. People in my research group post on it all the time. It's got a really diverse array of topics, really centered on water systems and environmental decision making. But we also have tutorials and tips on data science, statistics, machine learning. So it's really got a broad appeal.
Great. All right, one last question. So what are you especially jazzed about right now? What are you really into? What do you think is the next, what's the thing that's really doing it for you right now that you think might be worth sharing with our audience?
Great question. I mean, I'm jazzed on this course in general, I would say. This is the first time, we're releasing it, been working on it for a couple of years. But I would say in terms of data visualization, interactive data visualization, I'm really excited about. And I talked about that a little bit earlier, but if you look at things like the D3 data visualization library, again, for our multi-objective optimization applications, having interactive abilities when you're making data visualizations is really transformative. Working with stakeholders and being able to live without lags, without problems, without the computer crashing, demonstrate how changing assumptions or changing preferences really can change the outcome of your analysis is immensely powerful. And so that's what I'm excited about right now. And I would say that's part of kind of the cutting edge of where visual analytics as a field is going. I think we're still muted, Chris.
Tremendously promising here. So to answer the question for T. Martin and Mara, if you have questions about the specifics of the courses, what's involved, how they might be stackable, how it distinguishes from business analysis, analytics, just contact the folks at eCornell. There's a live chat, get help button right there on the Keynotes page. So that should be able to help you out. David Gold, tremendous pleasure. I hope someday we can hang in person, but in the meantime, take it easy. Thank you so much for joining us from New York, and let's stay in close touch, all right?
Definitely. Thanks so much for having me. This was really fun.
Oh, you bet. Me too. Thank you, audience, for joining. Again, this was recorded. If you want to view the recording or share the URL with anyone, again, it's free and open to all, so the recording should be available in just a few minutes. So I want to thank you all for joining us. Stay strong, stay safe. We'll see you all soon. Thank you so much. Bye, everybody.